Okay, so uh, we it's a digital world, and we all know what kind of data we deal with, right? So good old days, the mostly the data what you used to see, what was preserved, right, on a certain medium, not what we speak. Humans, how do we communicate? We we voice is one thing, right? Voice is a data, and I can communicate with the audience with image also. Agree? Yeah. And then I can communicate with people mixing both image and voice, plus the image I will make it as a motion image, which will become a video, right? So voice, image, video. Of course, text was there always, right? Text is something which we will preserve it onto a certain medium. So when I say onto a certain medium, earlier days, you could preserve only text on stones, right? You are on a leaf. That is where software becomes so important, right? You are able to also store the voice. Such a fantastic thing, right? Yeah. 100 years back, if you had to preserve music or a video, was that possible? No, right? Music was something you would have, you could give it from generation to generation. You could, your brain was a medium then where they could give the music or something, and video visualization was not possible, right? You could not even enact. What at max what you could have done is they will play a drama, and you'll go and you'll see the drama. But the amazing thing what we have in this era is these all can be preserved. These are called different data types. Agree? And that is why there is so much of boom on the software industry, right? Because you could do a whole lot of things with the data. And how the industry has gone is recently, right, from last year, YouTube. Now I search something on Google, and it also suggests me where that content is there in the YouTube video also. You can, it is not even searching for the content which is in the text, it is also searching in the video itself. You getting me? That's such an amazing thing. Yeah. So that is why it is so famous, right? Data engineering world has become so famous only for this reason. Yeah. And we as a data engineers, that is what we do, right? We all our use cases are dependent on this. Google is a front runner because it is able to think on the use cases, what requirements they want. Okay. Your human behavior, you go and you react to some event on Facebook, and you're giving them your behavior, what you like, what you dislike, to which community you come, to which religion you come, all your reactions. Earlier it was only human to human, right? If you reacted something on an event with your friend or a relative, and you would see a reaction from them, right? They will fight back or they will please. But now it is not. It's become a global world. You go and react on a social media, there is a data, they're capturing that data, and they will make you as a customer. You are the product. If somebody is giving something for free, then you are the product. This is told by Tim Cook and Google experts, right? If Google is giving for the Google engine free, no, they are using you. You are searching there, and all your search is being recorded. What you are searching. You getting me? You are a product there, right? So you are helping them to build that data, and with that data, they do so many things. You getting me? So why am I talking on this? Because that is the importance of data. And that is why this era, especially this year, you guys are so lucky that you have passed out or you have chosen an IT career, because this is the era which is going to rule. Next 10 years, 20 years, so many amazing things will happen. So today I was reading something, some study is done. Which country dreams about what? Okay. It is told by study that in India, we Indians dream a lot about snake. There's no reasoning, but most of us dream about snake, it seems. And in America, most of the people dream about losing teeth, it seems. There is no reasoning. Now experts will be after that. Why? But that is a survey done, right? Most of the people do that. But how it is done? They would have conducted some survey, and we would have fed that information to them. So when you are writing your APIs or whatever, your SQL, all that data is going, all junk is also put into the database. Earlier, 20 years back, if you have to talk about data, people used to be so conservative, right? Like, it's like, if I have to give you an analogy, when we were kids, we used to hardly have one or two dress. We used to get a new dress only for alternate Diwali or that, because there was no industry revolution. Dress were not available so easily. Now, everywhere, anybody you go, you will have a huge wardrobe collections, because industry revolution, right? It is being produced so much, and there is an appetite for people to buy. Machines, they do it fast. In a day, they will make so many dress and you can buy. Likewise, there is so much of hardware capacity available. 1 terabyte, 2 terabyte, they cost you so less. So it is so easy for you to store the data, and that is why any pattern, anything, you start storing the data. So today we will try to understand. Now you got to know about the data type, right? Voice, image, video, text is all the data types. How you store is what we are going to see. Okay. So traditionally, you all know about SQL. It is called structured query language, because in good old days, our human mind, it understands the data in a structured way. If I go and talk to my son on a structured query language, he will not understand. For him, they would be learning ABC or whatever words, right? They're trying to structure that grammar, syntax. That itself is a big thing. But data as such, when you do accounting, when you do any sort of your task management, you would do so many tasks, either be it a personal task or whatever, you would prefer to store them in a structured way. How would you do? You want to do 10 things in a day, what you will do? You will list them. So this is some structure, right? You will not plan your task like this, right? You will not write like this. Some people do. Some storekeeper, you would have seen, they will write the numbers here and there. You would have noticed it. So much of unstructured way of doing it, right? Yeah. So why do we make a kitchen? Can I store all the commodities what are required for a kitchen in a hall? No, right? I would want to keep them in a kitchen in a structured way, because it is easily accessible to me. I can go and take salt from here, masala from here, dal from here, so that it is easy for me to cook, and my mind would have been mapped, right? I know this is stored there. So I easily go pick it and cook it. So that is the structure. When you're talking about the structure, that is a structure. So there is a big concept called data structure. All computer science students might have learned. That is called data structure. How do you store the data? So the easiest way why Excel sheet became famous is the data is stored in a structure way. How is it stored? It is stored in a matrix way, rows and columns, right? We call it a matrix, n into m. It's a matrix, right? These many rows, n into m. Yeah, n stands for these many rows, right? M stands for these many columns. It is so easy for anybody to structure their data this way. So let us assume this is an employee database. In Excel sheet, you call it as a worksheet. And in the database world, you call it as a table. In a Java world, you call it as an object. It's everything is same. In XML world, you call it as an XML. In HTML world, the same becomes an HTML. Everything is same. So, but fundamentally, for you to understand these things, if you have made a model, we call it as a data model, right? So if you are able to understand it at a data model way, like this table, right? Yeah, it becomes more easier for you to become the programmer, right? So let us take an example. Let us take an example of employee, right? So employees, as an employee, I can collect so much of information about employee. What all I can collect? I can collect employee basic details of employee, their name, their gender, where they stay. I can collect employee address, right? I can collect employee insurance details. I can collect employee payroll. I can collect employee role and which project they are mapped. I can collect employee tasks. I can collect employee leaves. I can do so many things, right? As I go forward with my use cases, I can do so many things. But all these details, does it make sense if we have to, yeah, if we had to collect everything into one table? It is not a good idea to store everything into one table, right? Because I lose so much of time in scrolling the data. I will have to go. So now if I start writing the data this side, I will have to always scroll and I lose time, right? And it is not a good way of reading. Readability will be a problem. I would want to keep it simple. I would want to keep it more structured. We call it as a normalization. If you are a computer science engineer and you would have learned about RDBMS subject, you would have come across this word called normalization. What is normalization? You're trying to keep it simple. They've kept a very big word, normalization, right? But normalization is you're trying to be normal. What is normal? You're trying to keep it simple. Simple means very less number of attributes. So intentionally, I structured these topics like this. I will capture employee basic details in one table, employee address in another table, employee insurance in another table, payroll, role, and all I have modularized it. What is modularization? I have separated them. Although technology gives me the capability to store all this information in one table, but I don't want to do that, right? For my own readability, for my own simplicity, for maintainability, all right? You as a data engineers, you will model the data this way so that it is easier for anybody to see. Okay, they know you, the moment you told the table name is employee basic details, they will immediately get an idea. Oh, most probably it will have first name, last name, email. That's it. Employee basic details, table name. Yeah. And then when you talk about employee address, you know it is going to have only employee address. Okay. That is the beauty about modularization. So this helps. This is how you will have to, we call it as a model language. This is how, so now this is your employee table. You have, let us assume this is your employee basic table. It will have employee ID. It will have name, last name, date of birth, gender, and few other details. Okay. So when you do this, and each table generally you will have three common columns: last updated date, last updated user, last transaction ID. Okay. So employee basic details you do. So this is your meta. We call this as a metadata. That the first row, right? What is metadata? Metadata is something which talks on the data. What type of data it is? Your metadata is the table name is employee basic details, and this table is going to have this information. That is the metadata. That is meta information, right? You are writing a Java project. What Java project are you writing? I'm writing an HRMS application. That becomes a meta information about that project. What is a meta information of me? Okay, my name is Ramesh Kulkarni and I belong to this city. That could be the meta information. Not in depth, but at a very high level, right? So this becomes your meta information, and this is
sir. So one more time, sir. Meta.
Okay, so meta information is metadata is something which is a very high level abstract information. Yeah. So anything, any entity in the world, right? In and around you see everything is an entity around you. I am sitting here. I have a laptop. It becomes an entity because it has so many parameters, right? A laptop has a height, width, volume. It has this capacity, that capacity. It looks this color, that color. A human being as an entity, I can make it as an object. Room, fan. I see anything in and around me. I can make it as an object or an entity. So that information, that abstract information, what that entity will carry becomes an meta information. So this, we have taken an example of employee basic details. This employee ID, name, last name, this is all meta information, right? What this entity is going to have. And the same thing, this is in Excel sheet. What do you call this? You call it as a row, right? This is called as a cell. In database also, you call it as a row or a record. Okay, this is called column, right? In the database world, right? In Java, what happens? This record in Java, this becomes instance of a class or an object. We call it as an object or an instance of that class. In Java, you call this. In DB, you call this. In Excel sheet, you call it as a row. They all mean same. In XML, you will call it as a block, element, and all. Yeah. So this is how it is. This is how the data is represented. So we are talking on a SQL storage, right? Structure. The information is structured like this. It is called SQL. Now you have modularized the data. Okay. In Java also, it's an object oriented, right? Modularization means you're splitting. You as a let us assume you are a statistician and you are asked to collect the data. Government goes and asks you to collect the data of all the citizens. You go to door and collect the information. But you don't want to collect everything in one row, right? It's so cumbersome. You would want to collect the data like this, modularity. Okay. So when you do this module way of doing it, okay, when you do it a module way of doing it, so the next thing as a technology, what do you want? You would want to connect these tables, right? Because they all belong to, you want to fetch, when you want to fetch an information about an employee, you would want to fetch an information about all these things. If I come and ask you, give me the details of about all the employees. I mean, I come and I say, give me the record of Vishwa, and I want this information, right? And that information may reside in different tables. So that is where you need a join capability. You have to join these tables to get the data. Yeah. So when you get this join capability, so it becomes very easier. Okay. So we will stop here for a logical stop, just to, now that we got to understand the structured query language. So structured query language is what? The data is in structured way, and they have given you a capability to query on the data. Query means what? Query is nothing but a quest or a question. You're asking a question. You are asking the DB engine, give me this data. So that DB engine is giving you that data. You're querying. So they made a language. The way we are speaking English language, they made a SQL language. You write certain commands, you say select, the DB engine understands. The moment I write a select, it is going to select the data which is available in its database. It is going to select and give you what you want. You give a command saying insert the data, it will insert. You give a command called update, it will update. You give a command called delete. So they made a language out of it. So they named it as structured query language. So we'll stop here for this recording and then we will continue on the join.